for gold in big data. Mining for gold in big data, Wilson Fong.
Gold! 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 There's gold in them there hills, in big data. Actually, I'm not talking about mining real gold, although big data sounds like a town that might be in Alaska, where you might go digging for gold. I'm talking about big data in terms of large data sets. For example, Netflix. When you go make a choice in Netflix, when you pick a video, they record that, and they keep a history of what you pick. And there's a reason they want to do that, because they want to recommend new videos for you to watch, so you can spend more money watching more videos. So all those clicks from all their customers, millions of customers, all the choices they've made, they will mine that for information. Little nuggets of information about how you select your movies, what you like, what other people like, how you pick movies like someone else, and if there's something that they haven't seen, that you haven't seen, they've seen, and you have a similar pattern, they might suggest that new video to you. And then, of course, you say, hey, I like that actor in that movie, so I'll get that movie. So that's how they make money. In fact, it's worth at least $1 million to Netflix, because that was the prize offered to people who were digging for gold to come up and build such a system for them, these recommender systems. So tonight, I'm going to tell you a little bit about big data, what the characteristics are of big data, how to actually mine big data, the tools that are used to mine big data, called machine learning, and then how you can take advantage of it. Give you some suggestions that you can take action and see if you can find your own gold. So again, big data is just a lot of data. It may be specific, it might be census data, it might be click-through data. If you're on Amazon, if you click on something, they record that. How long you spend on a page, they'll probably record that too. What you buy, they'll record that. And again, they'll run it through this system, this machine learning system, and then they'll generate recommendations for you. And it might be totally different from what you actually pick. You can pick something in the movies, but because someone else who has a similar pattern as you went and bought an exercise machine, they may recommend that exercise machine to you. So these things that are not logically connected to you can be interconnected for whatever reason. Maybe you're watching too many movies, you've been sitting on the couch for too long, you need to exercise. But you don't really need to understand it, you just have to know that this machine data system will predict that particular, or provide a recommendation for that exercise machine. So again, this data could be hundreds of records, could be thousands, could be millions, tens of millions. And then the other aspect of big data is its complexity, the dimensionality of the data. There could be lots of different attributes they could be capturing. For example, they could be capturing where you made your purchase, what the size was, when you did it, what time of day, and then what other things you clicked afterwards, or bought afterwards, or what you bought with it. And then the next aspect of it is, because there's so much data, you and I can't grasp or get any idea of how to interpret that data and get anything useful from it. So you need a computer. And that computer has to have certain kinds of programming on it, and then that whole section is called machine learning systems. And I'm going to go into a little bit of detail on what machine learning systems are and how they are used to generate these recommender systems or classification systems that can be built from it. Now when you say, how does it generate a recommendation? How does Netflix do that? well, what they've done is they've done essentially a statistical analysis of everybody's information that they've collected. They've created a model of how they think is important, what they think is important in and how people make decisions about what videos that they watch. And based on your pattern, they'll run your pattern through, and then they'll generate all the movies that maybe you haven't seen that could be a possible movie that you want. And they may have a rating with it. 99%, I'm pretty sure that this person's going to really like this movie, and so you'll see it next time you log in. Hey, Wilson, why don't you watch this other movie? I can't. There's a Bruce Willis movie, but I can't remember the name of it right now. But the machinery that goes with it, called machine learning systems, there are 4 of them, or 5 of them I'm going to try to cover tonight. One of them is called a linear regression. Now, if you've ever plotted a line through some data, you've essentially done a linear regression in one dimension. And that's what that is in the simplest case. For the case where there's hundreds or tens of thousands of dimensions, you're plotting it through some high-dimensional data. So you're plotting not a line, but a hypersurface, is what they call it. And you're just essentially drawing a linear surface through all this data that's used to fit what all these data tells you based on a given pattern will predict. So if you've done a financial forecast, for example, if you did a plot of advertising dollars versus sales, and you base it on previous experience, then you've done something similar. And so I know if I spend this much money, I probably will get that amount of sales. Or similarly, if I've done this much advertising, I should get this many members coming in for Toastmasters, for example. Because if I don't advertise, I'm not going to get very many members. The second thing is called a logistics regression. Logistics is very similar to a linear regression, except the data is not continuous. Where dollars spent, or number of members coming in, or number of sales, it's a continuous variable. You can have 1 to 1,000 or whatever. Whereas in a logistic problem, you either have as your answer yes or no. He has the flu or he doesn't have the flu. They're present or they're not present. Or an example of where this is used is, the zip code on your envelope. It has a bunch of handwritten numbers, and in the post office, usually a person reads through that and classifies each piece of mail based on the zip code. Now they have machines, they've developed a machine that will do that automatically. And this machine has to read everybody's handwriting. And you know how everybody's handwriting can be, and distinguish each number in that zip code. And they wanted a system that can predict it at a 6% error rate, because that's how good a human can do it at. And they wanted to replace the human with a computer, because a computer's a little cheaper, and they don't ever get tired. So using machine learning and either logistic regression or something called the next thing I want to cover was a neural net, they were able to teach the computer how to recognize a zip code. And I just mentioned a neural net, and all a neural net is a system where you have a bunch of inputs, nodes is what they're called, and outputs. And you have a bunch of layers of these nodes. So you can have your input node, next layer, and then you just connect them all up. And so input might be the image of the area code that they've taken. and then trying to recognize that particular digit. So they've done some processing to separate out each digit separately, and then they're going to input the information into this end, going to create some output, and then send it to the next layer, and then the next layer. And the more number of nodes and number of layers you have, the more complexity you can model. And so they're able to create and get pretty much close to 6% or better than 6%. And that's one of the successes of machine learning. I don't have time to cover the rest that I wanted to, but if you wanted to make some goal out of this, you can go and become a machine learning system engineer and create these systems. And you can learn it on the free, from the web. There are free courses that you can take. You only need a computer and some time to spend to learn this stuff. Thank you.